Welcome to Penrose Learning, where we make understanding easy.
You start by prioritizing safety and getting immediate, useful data. Disconnect mains and safely discharge filter capacitors with a 10 kiloohm, 2-watt resistor. This protects you and the circuit. Next, perform a thorough visual inspection for burnt resistors, swollen capacitors, lifted solder joints, or cracked PCB traces. Once done, measure fuse continuity and DC supply rails, record voltages and polarity. These first steps identify obvious failures and create a baseline you'll use for targeted troubleshooting. Now, you move into focused component-level testing to find root causes. Use diode mode to test rectifiers and base emitter junctions, and transistor check to verify gain and shorts. Desolder if in-circuit readings are ambiguous. Measure resistor values against markings and use an ESR meter on electrolytic capacitors. Replace any with high ESR or out-of-tolerance values. Once you identify failures, reflow or replace parts with proper flux and controlled heat. Make sure to use heat sinks on sensitive semiconductors to avoid damage. Finish by reassembling and powering up cautiously. Use a variac or current-limited bench supply to bring voltage up slowly while watching for smoke, smell, or excessive heat. Once stable, set output transistor bias and DC offset to factory or measured values. Verify with a dummy load and an oscilloscope to check for clipping, oscillation, or distortion. If issues remain, isolate amplifier stages, swap in known good modules or parts, and document voltages and waveforms for a final diagnosis. This will reveal intermittent or hidden faults.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.